Okay. So I want to talk about analytic geometry. So of course all of you have some idea what geometry is. So geometry in its ancient form actually starts with the studying of shapes and figures. But analytic geometry wants to study geometry from algebraic point of view. So algebra and arithmetic are related to numbers. Geometry is usually related to figures and shapes. Okay, but we want to find a connection between geometry and algebra. Okay, so it means that we need to find a way to express geometrical concepts in the form of numbers. Yes? So if I ask you what is the most primitive object in geometry, what is that? So you know that geometry consists of points, lines, triangles, circles, ellipses, and everything. Okay, these things. Even if you go to 3 dimensions, cubes, rectangular cubes, pyramids, and everything. Now, if I ask you what is the most fundamental geometric object, what is that?
Point.
It's a point, yes? So a point is a fundamental geometric object for us. And then I want to, first of all, give it an algebraic meaning, yes? So what does it mean? And all of you know about that. So, of course, it depends in how many dimensions we are working. But in this lesson, we are only working in 2 dimensions. 2 dimensions means that, for example, you can assume that these objects are lying on the plane or on this whiteboard. Yes? Yes?
I touched some. We'll move.
Yes. Yeah. Okay, so here assume that I have a coordinate system here. Yes? And all of you are familiar with the coordinate system, especially from your self-study in Math 1C. So I have one coordinate x, one coordinate y, so this is the x-axis and this is the y-axis, and here I have the origin. We usually take them orthogonal or perpendicular to each other. I have these 2 axes. On the right hand side, x's are positive, on the left hand side, x's are negative. When I go up, the y's become positive and the y's become negative when I go down. And we know that every point now for us is 2 numbers. Yes? So if I give you this point, for example, if I have 1, 2, 3, and if I have 1, 2, for example, and then if I draw a line parallel to the x-axis from the point 2 and a line parallel to the y-axis from point 3, whenever they intersect, this intersection gives me a point on the plane. For example, let me call it A, and then I would say that these numbers are the coordinates of that point. Yes? So I would say that the point x coordinate of point A is 3, the y coordinate of this point is 2. Okay? Now if I ask you what are 3 and 2, they are of course not geometrical objects, they are just simply numbers, 3 and 2. But 3 and 2 are representing together a point for me on this plane. So if I want to address a point which is a geometric object, one way to do that is to take my whiteboard pen and put some specify a point for you on the whiteboard. But probably a better way for me to do is to give you 2 numbers, for example, in this case 3 and 2, and if you know the rule, you can immediately locate that point for me. So what I want to say is that point is a geometric object, numbers are algebraic objects. But now, using this language, you immediately realize you have connected this geometric object to two algebraic numbers, to two algebraic objects. So from now on, in analytic geometry, which is that form of geometry in which geometric concepts are being represented by algebraic objects, that is called analytic geometry. So in principle, we want to discuss about this analytic geometry, and that is very powerful, sometimes even more powerful than the traditional geometry. Why? Because you can use all the rules and powers in algebra to discover something in geometry. Is that understandable? So working with numbers might be a little bit easier for us than working with figures and shapes, and then this will give us the opportunity to discover a lot of interesting properties even for shapes and figures, but using algebra. Is that understandable? So that is the meaning of analytic geometry. Okay, I don't want to discuss about that so much, but hopefully you know that if my point has x coordinate negative and y coordinate positive, by the way, these are the names that you might you know. So you see that I have divided my plane, the plane of whiteboard, which continues to infinity in all directions. So don't think that a rectangle is a plane. Plane doesn't have any borders. So if you have a real plane, it divides the universe into three parts. One part, the points on the plane itself, one part on the one side, one part on the other side. So when I say a plane, we cannot imagine a border for a plane. It continues forever. Yes? So when I say that I am on this plane, these two lines are actually partitioning the plane that I am working on into four quadrants. And there is a convention. This quadrant is called first quadrant, yes? So this is called the first quadrant. And then if you go counterclockwise, that is convention. This is the second quadrant, and that is the third quadrant, and that is the fourth quadrant, yes? So this you need to know. That's a convention. People could have chosen it the other way around, but they have chosen it in this direction. Okay, so in the first quadrant, this point, this number is called the x coordinate of my point. This number is called the y coordinate. It is completely clear that x and y coordinates can be positive, 0, or even negative. Yes? If I have a point that I know it is in the first quadrant, what can you say about the sign of these x and y coordinates? It's clear that it is in the first quadrant. If it is in the first quadrant, both x and y should be positive. And if you are in the second quadrant, what is x coordinate?
Negative.
What is y coordinate? Positive. And if you go to the third one,
Both of them negative.
both of them negative. If you go here, x is positive, y is negative. If you have a point which lies on the x-axis, what can you say about its y coordinate? It is 0. And if you have a point which lies on the y coordinate, what can you say about the x coordinate?
0.
It is 0. And if a point is exactly the origin, both coordinates are 0. So these elementary and simple things you can actually you have studied on your own in self-study Math 1C, if you remember. So I will not discuss that much here, but whenever I ask you to determine a point in analytic geometry, what is the meaning of this question? For example, I ask you a question and I ask you, find a point for me with this property. How you should understand this question in analytic geometry? Yes?
You are supposed to give the coordinates.
Coordinates. So whenever in analytic geometry, if the question is related to finding or locating a point, this means find its x and y coordinates. That is the meaning of this question. Yes? Now, one thing that I want you to know is very simple. I want you to know that if I give you the coordinates of 2 points, how can I calculate the distance between these 2 points? We want to discover the formula for that. That is called the distance formula. and unfortunately it is included in the formula sheet, but I really want you to memorize that after learning that. So let us discover this together here, okay? Let me give you some example. For example, let me take this one away. For the time being, I want to ask your opinion about that. Then we can prove it mathematically, and then we can solve some problems using that. So let us having this point here, and let me, for example, I have another point. Let me call it B. This is point, for example, 4, 5, 6, and let me make the other one negative. So 1, 2, 3. So I will take this time, this point. Yes? So 6, and this is minus 3. So if I call this point point B, what are the coordinates of this point? 6 and minus 3. Yes? Now my question is that I want to find the distance between these 2 points. Yes? What is the meaning? It means that I need to put my ruler, assume that my ruler is a very precise ruler. So you see that in geometry, you have to have measuring tools, but in algebra, you can calculate the numbers exactly. So that is the whole point of algebra. Okay, so now I want to calculate, not measure. Okay, I want to calculate the distance, the exact distance between this point and that point if I have given you the coordinates as you see here. Okay, so what is your proposal? So what should I do? Yes?
You could use Pythagoras, or how you pronounce it.
Yes? Theorem. It's good to know this word. It's very ubiquitous in mathematics. Theorem. Theorem is a true statement. These are, by the way, parts of our lesson. It's better to learn them. A theorem is a true statement. But of course, we usually call very important true statements theorems. In principle, any true statement in mathematics could be called a theorem, but when we call a theorem, it means that this is actually very important. We have given this a name theorem. Okay, so how should I do that? Can you elaborate on that, please?
Yeah, we know the base in the triangle is 3 because from the middle of the line,
Yes?
it's 3.
Yes, so you are measuring this, yes?
Yeah.
Okay, how will you do that? So in principle, I have to continue this line. Yes? This angle will be 90 degrees. And then from here to here, it is very easy to understand because you are telling me that the x-coordinate of point B is 6, the x-coordinate of point A is 3. So it means that the distance from here to here is exactly 3, but hopefully you agree that the distance here and the distance here are exactly the same. That is geometrical argument, by the way. The reason that this one is equal to this one is because this shape is a rectangle. So you see, it's a mixture of algebra and geometry together, okay? So then if I ask you what this number is, you calculated this one to be 3. How did you do that? You took this one and you subtracted from here. So this is 6 minus 3, yes? And if I ask you what is this length, what is this length, because I want to calculate this length now. What is this one? So what is this length? It is 5. But how can I calculate 5 using minus 3 and 2? Yes?
2 minus minus 3.
2 minus minus 3, yes? So 2 minus minus 3 gives you 5. So, and then 5, and this is 3, you can immediately write the Pythagoras theorem and write that the length of AB, if you want, I can put this one, but in your book there is no difference between AB length and AB. And I don't want to do that. I want to follow the book. When I write AB squared, it is completely clear this means the length. Otherwise, if I have a line segment, how should I square it? Squaring a number means multiplying that number by itself. So there is no matter of confusion if I do not specify that this is a length. Otherwise, it doesn't make sense. So AB squared becomes what? 5 to the power of 2 plus 3 to the power of 2, which is 25 plus 9, which is 34. But then I want to find AB. So what is AB? AB is the square root of 34. Length units. Yes? Exactly. And I mean exactly, you have to keep it like this. Otherwise, if I tell you that answer to 1 or 2 decimal points, then you have to calculate it using the calculator. But this is the point that I want you to stop if I ask you this. Okay? Okay, now can you tell me how we can discover a formula for that in general? Okay, so what I'm saying is that I consider this case. For example, I have this, and I have, for example, this is my coordinate system here. And I give you a point A, for example, and I tell you that the coordinates of this point are x1 and y1. And I give you another point B, this is the x-axis and this is the y-axis. Yes, and I tell you that the coordinates are x2 and y2. So yes, x, this means x sub 1, the first x, the first y, the second x, the second y. In some books they write x and they put an index A, meaning the x coordinate of point A. Might be that is a little bit better, okay? But anyway, is that understandable? Are you confused with x1 or y1 and something like that? Is the notation understandable for everyone? Yes or no?
Yes.
Okay. Now we want to discover a formula. So I want to find the distance between these 2 points, yes? And this is called V. Assume that I give you the points A and B. What is the meaning of this sentence in analytic geometry? Means that I give you 2 numbers for A as x and y coordinates. I give you 2 numbers for B as x and y coordinates. And I want you to find a formula for me so that I can calculate D exactly. Yes? That is exactly the same idea, yes? So can you help me to do that? If I want to find the distance, how should I do that? Yes?
Well, I mean, the square root of, in parentheses, x1 minus x2 to the 2 plus y1 minus y1 minus y2 to the 2.
Yes, exactly. But how did you do that? Because you told yourself, for example, that if I draw a line from here and a line from here, yes, and I can do a line from here to here, not random lines, yes? So these 2 lines that I drew are parallel to the y, and this line that I drew is parallel to the x, yes? So if I ask you, do I know this distance? Yes, what is that distance?
It's x1.
In this figure, it is x2 minus x1 because b is on the right hand side. But it doesn't matter. So what I'm saying is that, so you calculate here x1 minus x, so x2 minus x1, yes? This distance is that one, yes? And if I ask you what is this distance, and by the way, this distance from here to here is exactly equal to this distance. If this is x2 minus x1, from here to here is also x2 minus x1. But what is from here to here? If I continue in this direction, if I ask you what is this number, then you will answer y2 minus y1, which is exactly equal to that one, y2 minus y1. Yes? And now if I ask you what is d, you can write d squared. D squared is equal to this length to power 2, which is x2 minus x1 to power 2, plus the other number to power 2, which is y2 minus y1 to power 2. Yes? But I am interested to find d, so I have to take the square root. Yes? When you take a square root, do you remember the very beginning in Math 1C, I told you that whenever you take a square root to find an unknown, you have to put plus and minus. But here I am saying that you don't need to, but why? In mathematics, there are no exceptions unless there is a reason for that. Always and always, when you want to find an unknown by taking the square roots, you have to put plus and minus. If you don't do that, there should be a reason, convincing reason why we don't do that. Yes?
We're trying to find a length.
And a length cannot be negative. Thank you. So that is the formula we just discovered. Okay, I want you to memorize that, or at least understand it every time. I want to have it in memory. If you want, you use it. Yes?
Does this apply to every situation?
Every situation.
Even if B is on the left?
Yes, let us answer. This is a good question. Do you think that if I change B and bring it B to the left, I have to change the formula? This is a good question. Let me just ask it once more. So what Ali is concerned about, which is actually very good, he's telling, okay, this is just one particular case that you calculated the formula for me. What happens if B, instead of being on the right, I take B on the left of A? Then, of course, I have to switch x1 minus x2, because now x1 is larger. Yes? But do I really need to take care of that? Yes, Simon?
Since the number gets multiplied by itself, then it is, if the number then would be negative, a negative times a negative just becomes another positive.
Positive
So it doesn't
number.
matter.
So it doesn't matter. Or in other words, because I have an even power here, it doesn't matter in which order I write them. This is important to understand. You see, if I have A minus B, if I have B minus A, of course they are different. But if I have A minus B to power 2, and if I have B minus A again to power 2, they are exactly equal. There is no difference between them. I want you to understand why. Because A minus B to power 2 can be written as minus A B minus A to power 2. First of all, do you agree with this one? If I multiply this minus sign in, B becomes negative, B is negative. A becomes positive, A is positive. So this equality is valid because what I have here is exactly what I have here. Yes? But then, what is the meaning of this minus? The meaning of this minus, if you want to be clear, this means minus 1 times B minus A to power 2. Yes? And then you have a rule, you know, if I have two numbers multiplied and I want to square it, I can square the first one, I can square the second one, and then multiply. Yes? But minus 1 to power 2 is 1. And 1 multiplied by everything is the same number. Not everything. Any number, it is the same number. So hopefully now you agree that these two things are the same. So you are completely right, but luckily our formula is not sensitive to be very careful about how to replace x1 and x2 in the pair of brackets. Yes or no?
Yes.
Understandable? Okay. And a very common mistake I don't know some students make, I have seen students think that they can take this square root away and take these powers away as well. This is completely wrong. Be careful. Let me just write it once and then cross it over. So you see, square root of a squared plus b squared, if you think you can write it as a plus b, that is totally wrong. Be careful. So this formula, don't think that you can simplify this formula more. No, this formula is like this. And if you want to calculate it, there is only one way. Calculate this difference, square it. Calculate this difference, square it, add the squares, and whatever you get, take the square root at the end. There is no shortcut for that. Is that understandable? So now let me ask you one question. I want you to tell it in words. If someone tells you what this formula is useful for, what do you say? When this formula is used? Yes?
Finding the distance between 2 points on a
2 points with given coordinates.
given coordinate.
Yes?
On a coordinate.
I give you 2 points. In analytic geometry, it doesn't mean that I give you really points. I give you 2 numbers for the point, 2 numbers for the other point, and then I ask you what is the distance between these 2 points. This is the formula which comes into game when you want to calculate the distance, the exact distance. Is that clear? So let me give you a very, very simple example and then try to increase the level. Okay, so here I would write this example. Determine the distance between the points A with coordinates -1, -3 and B with coordinates -5 and 2. Okay, so what I'm supposed to do? Let us write a formula to memorize that. But you learn that your formula is not sensitive to the order, but it is always good to be organized. Okay? So what I would write, let me write it with a different symbol, different notation. I will write my formula in this form. xa minus x sub b to the power of 2. What do I mean by this notation? I mean the x coordinate for which point? For point A. For this notation, it's a very good notation. You don't need to write and explain so many things. And then I would write, for example, the same thing here. Y A minus y b to the power of 2. This I repeat to memorize, because I learned what is behind that. If someone tells you what is, by the way, this is geometrical argument, because I use the Pythagoras theorem. So it means that even though I am doing algebra, but this algebra was not in place if I didn't know about the Pythagoras theorem, which is a geometric theorem. So that's important. So that's a mixture of algebra and geometry, helping each other to solve harder problems. Okay, so here I would write the square root of, so you have to be careful, just x sub a means the x coordinate of a, I go and read it, it's -1. The formula contains a negative sign. X sub b itself is negative. I don't want you to write all these details, but I really want you to not make mistakes at all. So it depends on you. If you want to do it faster, of course do it. And then y sub a is the y coordinate of point A is -3. There is a negative sign in the formula. And then y of b is 2. I will write all the details for the first example at least. Then I will have a square root of -1 minus 5 is +5 to the power of 2 plus -3 minus 2 to the power of 2. Now I can write it as a square root of -1 plus 5 is +4 to power 2. I'm writing too many details. You really don't need to do that. -5 to the power of 2. Yes? And then the answer becomes, how should I calculate this? I need to calculate this one first, which is 16. Calculate this one, which is +25, and then add them. And then if I calculate this, it becomes a square root of 41 exactly, length units. So the distance between these 2 points, I can also write it as AB equals to square root of 41. I told you technically it is better to write this symbol, parallel lines, like the length of a vector. But let us just ignore that because your book hasn't talked about that. So I'm using AB interchangeably for the length and for the segment itself. But when I write AB is equal to that, it means that I am talking about the length. Yes? Any questions? Okay. So, let me give you another example. Now we can go to okay, so consider the points A with coordinates, let me write A and 5 and B 2 and 3. Determine A, little a, so that the distance from A to B becomes 10 length units. So that is a simple question. I give you the coordinates of the points and I ask you to find the distance. This is the straightforward question. The other question is also I want you to learn is this one, but of course that is exactly the same concept. Here, can I say the point B is given? Yes, because the coordinates are given. Can I say the point A is given? No, because still the x coordinate is missing. But instead of that, I have provided you an extra piece of information. I have told you that the distance from A to B is 10 length units. And then using that, I want to find that point A. Yes? Okay, but because the name of this lesson is Analytic Geometry, before doing algebra, it is extremely important for me to understand it from geometrical point of view. How do you analyze the problem, even without writing anything? Do you think such a point exists? Or might be it exists and sometimes it doesn't exist? These are important questions you need to ask yourself because this will give you a lot of good intuition about what is going on behind the calculations. Okay, can you tell me, do you think is it always possible to fine-tune this A so that the distance between these 2 points become 10? Or sometimes it is not possible, sometimes there are 2 points. How many points are there, by the way? Is it possible that I have more than 1 point whose distance from here is 10? Yes or no, by the way? If I give you, these are good questions to ask. Don't try to be very precise in your sketching, it takes a long time. B is given, so assume that B is given, B is here. If I ask you, let me ask you these questions. How many points, of course, whenever I talk about points, I do not talk about points here in a space. I'm always talking about the points on the plane. How many points on the plane are there so that the distance of those points to this point is 10 length units? Yes?
Infinitely many.
Infinitely many. Agree? So, but these infinitely many are random points or no? They are organized. Can you give me, so do you know, by the way, this is the word that I want you to learn. This is called locus. Locus means geometric location. And the plural form is loci. I want you to learn these words. Okay, so I can say, can you tell me what is the locus of points on the plane whose distance to B is 10 length unit. Yes, Oscar?
Well, all points within a 10 length unit radius of B.
So can you tell me what is the locus at the end? The locus means the geometric location of the points. So when I say what is the locus, I mean, can you tell me a shape, a figure, or whatever which contains all those points with that property? That is called the locus of those points with that geometric property. Yes, Haya? Yeah, what Oscar said is completely right, but can you just say in other words? It's a circle. Its circle is not complete. When you say it's a circle, I agree, but it is a circle with what is the center, what is the radius?
With radius 10.
Radius 10, center? Center? B. So you have to, when you say it's a circle, it's not a complete sentence yet in mathematics. Which circle? For specifying a circle, you need to give me the center, you need to give me the radius. Now it is complete. So what you are claiming that the locus is a circle centered here, yes, whose radius is how much? Is 10. So if I choose any point here, any point on this circle and connect it to the center, and if I measure this distance, what is this distance by the definition of the circle? 10. So all these points are 10 centimeters, 10 length unit away from B. Can you find other points except these points?
No.
No, because if I go beyond that, the length will be larger. If I go inside, the length becomes smaller. So these are the only points. So this means this circle is the locus of all points on the plane whose distance to the B is equal to exactly 10 length units. Okay? So if I don't give you this, so you see that there are infinitely many points. But now I have given you also the point A with a fixed y coordinate. How many points do you think are there? Yes, Tim? 2. Can you imagine that y is 2 before calculation? Because here in this lesson, I want you to learn both algebra and geometry hand in hand. Yes? So how should you do that? How do you imagine there are 2 points? Yes? 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 Okay. How many of you agree with that argument? How many of you raise your hands? How many of you completely agree with the argument? So Tim is saying that this point, by the way, if I ask you, let me test your understanding. What is the locus of these points? How do you understand this question? What is the locus? What is the locus of these points? What is the meaning of this question? I want you to understand. It means that if you start changing A, what will be the shape on which all these points lie? That is the meaning of the locus. And you think it made it exactly correct. So because the y coordinate is fixed, if I start changing A, what will happen for this A? If I increase A, it goes to the right, but on the height 5. And if I decrease, it goes to the left. So that is correct. The locus of this point is a horizontal line. But you immediately conclude that there are 2 points. Because you were thinking that if I have this, and if I draw this horizontal line, yes, this will intersect my circle at 2 points. But is it the only possibility? No, because who knows that this is very close to the center? Unless you draw it and conclude it. Do you understand what I mean? Because might be this point is higher and you draw a horizontal line, there are no intersection points. So it might happen that you have 2 points for this. It might happen that you don't have any points at all. But it might happen that you can have exactly 1 single point, and if you are completely lucky that this line exactly touches the circle at 1 point. So I want you to understand that the answer to this question in general depends to the situation of the point and the circle. Depending on the relative position of these two, I might have 2 points for this, 2 answers, or might be 1 answer or no answers at all. If you want to do that, of course you can have a good sketch and try to understand which situation will happen. Yes? So how should I do that? If I want to do that, I go to the coordinate system. You don't need to be precise at all. 2 and 3, 2 units. Yes? 3 is this one. This is point B. And then A is what? A is A and 5. So here 4 and 5. Can I make A clear yet? No. But one thing is clear. Whatever this A is, A lies on this line. Agree? This is 5. So that is the locus of these points. This is the locus of these points. And then now if I draw the circle, Tim is completely right. Might be you have done this intuition, but in general we don't know. Because the circle centered at this one with radius 10 is much bigger than this one, so it will cut this line at 2 points. Yes or no? Yes or no?
Yes.
Okay. So now the question, this is geometrical way, but geometry cannot continue more. Okay? You have to use algebra now. Because I want to find the exact value of this A. Okay, can you tell me, if you need an instrument, I will give it to you. Which instrument you need to find those points from geometrical point of view? Yeah, compass.
Yeah.
So you take your compass and then open it 10 centimeters, for example, put it here and draw a circle. And then the intersection points are fine, you can find them, and those are the points. That is geometrical. We cannot do more than that. But algebraically, we can do actually much better. We can find exact values for A. Okay, how can I calculate that exact value? Can you help me to do that? How can I calculate that exact value?
You can use
The distance formula. Yes, so what I write, I would say that you are telling me that AB is 10. This is the information that you have given to me. But I know there is a formula for the distance from A to B. What is that? X of A minus X of B squared, Y of A minus Y of B squared is equal to 10. Yes? And then instead of X of A, you have given me that this is little a. So instead of X of A, what I write little a minus X of B you have given me to be 2 to the power of 2. And instead of Y of A, you have given me 5. And for Y of B, what? 3. So this question, which was for locating a point, I want to find a point, turns it into an equation in algebra. So it means that if I solve this equation algebraically, then I have the answer to this geometry problem. So how should I solve that, by the way? Do you have any suggestions for me? I want to find, not guess. How can I find that? Yes?
So I would square both sides.
Before square, yes, you are right. But before doing that, if you don't mind, let me calculate this. 5 minus 3 is how much? 2. 2 to the power of 2 is 4. Okay? I square both sides, yes? I don't know what is below, but I know that the square root of that one is 10. So it means that this number itself is how much? Is?
100.
100. How should I solve this one now? Yes?
Move forward to the other side.
Move forward to the other side. A minus 2 to the power of 2 is what? 96. And then I need to find A minus 2. So what is A minus 2? Can you tell me?
It's square root of 96.
How many of you agrees with this one? A square root of 96, which is not the complete number. So let us keep it like that. Then what is A? Can you tell me? I move 2 to the other side. So it is 2 plus square root of 96.
Yes.
Agree with this one or not?
Yes.
You shouldn't agree. According to Tim's analysis, we actually learned that how many points there should be. There should be 2 points.
Yes.
But how many points I got? 1 point. So there is a reason behind that. So this, I want you to understand the connection between algebra and geometry. It's important. We realize that definitely there should be 2 points by this picture, and this is not possible to be wrong. It was so simple that everyone agreed. So why I'm getting 1 answer only? I was expecting 2 answers, not from algebraic points of view. It's extremely important. From geometrical points of view, I realized there are 2. But now I see there is 1. It means that I have done something wrong in my algebra. Yes? What is that? What is that one?
A minus 2 should be equal to plus minus.
Plus and minus. I told you just now. Whenever you want to take a square root to find an unknown, you have to put plus or minus unless you have a reason that that number should be positive. Here we don't have any reason for that. So this means this is the wrong part. This part I have to put what? Plus and minus. And when I move it to the other side, it becomes plus and minus. And then it becomes 2 answers. Either A is 2 plus the square root of 96, and the other one was 2 minus the square root of 96. So these kind of things are actually extremely important to understand. So you see, if I hadn't done this, and I had calculated just 1 single point, it might happen that I didn't notice that I have made a mistake, unless I am very skillful in my algebra. So from now on, remember, whenever you want to find an unknown and you are taking a square root, you have to put plus and minus. This doesn't mean, I have seen even some teachers say square root of 4 is plus or minus 2. No, square root of 4 is only 2, not plus and minus 2. But if x squared is 4 and I ask you to find x, then you don't write x is a square root of 4. You write x is what? Plus and minus a square root of 4. A square root of 4 is again one number, and that is 2. But the plus minus is coming before that, not because the square root of 4 is plus or minus 2. Okay? So that's extremely important to understand. So here we use this formula. Okay, another part of the lesson today, which is very important, I want you to find the midpoint of a line segment. Okay? Of course, in usual geometry, you don't have any problems with that. What do you need to find the midpoint of a line segment using the normal geometry? What instruments do you need? For example, compass can work, or might be a precise ruler can work. Yes, you can measure the length and then find the middle point. So you know what the middle point is. But now, in analytic geometry, how should I read the question? In normal geometry, I give you 2 points, and I ask you to find the midpoint. What do? You take your ruler and draw this line, and you can measure it, whatever, and you can find the middle point. That's it. But in analytic geometry, when I give you 2 points, it means that I give you a pair of numbers and a pair of numbers, yes?
The point in the middle, not the distance.
Yes, the midpoint, not the distance. But how should I find the midpoint? What is the meaning of this question in analytic geometry? I mean, when I am done. When I say 2 points are given, what do I mean? When I say 2 points in analytic geometry are given, means the coordinates of the points are given. And when I ask you find the midpoint, I mean find the
average of...
No, I don't want you to give me the method. The method is correct.
Yeah.
But what is the meaning of the midpoint? Finding the midpoint means find the coordinates of the midpoint. That's what I want to say. Okay, so let us see that if I can discover something. Let us discover a formula together, okay? Before doing that, so let me take 1, 2, for example, and 1. Of course, this is not hard. You might be able to guess, but guessing is not good because I want to find a formula for that. Yes, and this is point A, for example. And then I will give you a point 3 and 4, and then let me make it x3. This big. Okay. If I ask you what is the midpoint, of course this question is very simple. You just connect these 2 points and then use your ruler to find the middle point. Might be you are able to guess what is the midpoint here. I mean this point. If I call it M for midpoint, my question is that what are the numbers that I have to write here and there for finding my M? And Rasmus told me the answer. That is correct, but why? Is the question clear? If I ask you what are the coordinates of point A, you would say 2 and 1. So the numbers for A are given. The coordinates for B are also given. 4 and 3. Now my question is that what are these 2 question marks if I give you 2 points and I tell you that M is the midpoint of this line segment? What are those numbers and why? The why part is important. Of course, I can give you the formula, you can memorize it. So Rasmus told us that take the average, and the answer is correct. So you add 2 and 4 and find the middle one, which is 2 plus 4, 6 divided by 2, 3. This is this number. And you do the same thing for y's. 1 plus 3 is 4, divided by 2 is 2. So this would be 2. And if you draw a precise picture, you immediately realize the x coordinate is really 3 and the y coordinate is really 2. But why do you think this formula will work? In this simple picture, do you have any idea why this is the correct formula? Yes?
I don't know exactly, but I guess the middle line from the middle point is exactly 45 degrees from both.
No, there is no guarantee that is this 45 degree in this case. This is exceptional. Yes, in this case you are right because this length and that length are the same. So this right angle triangle is also an isosceles triangle. So that is 45. But this is not always the case. Do you agree? If I change this point very, very long and lower, this is different. So you need to have a good reason why this is the case. So, for example, we can use trigonometry, yes? So if I continue this line, and this angle, let me call it alpha. Okay, so what can I do here? So I don't know this number, so let me call this point is xm. Of course, here it is very clear, but let us assume that we don't know this. Okay, if I ask you what is cosine alpha, I can calculate cosine alpha in 2 different ways. Yes? One in this smaller triangle, one in this bigger triangle. Yes? Because they are the same. So, can you tell me, if I write cosine alpha in the smaller triangle, what will happen? Can you tell me what is this length? No, of course you know here. Well, okay, so let me change my idea. It might be this is a little bit distracting. So here I will take this point and this point. I give you this point to be, you know that, XA. This point, the length here is XB. And then I connect this point to that point, and this is the midpoint M. I call this one XM. Still, I don't know. XA is given, XB is given, XM is missing. And I want to find XM. I am saying that this angle is something. In your case, you told the correct angle. Here in this case it is 45, but in general there is no guarantee that this is 45, or still I don't. Okay, can you tell me in this smaller triangle, what is cosine of alpha? Cosine of alpha is the adjacent side divided by the hypotenuse. Agree? So what is the adjacent side? xm minus xa divided by am. Agree? Now let me do cosine alpha once more, but for the bigger triangle, because that is the same alpha. So what is cosine alpha in the bigger triangle? Can you help me to write it down now?
xb minus
Yes?
xb minus xa
Adjacent side this time is this one, so it becomes xb minus xm
divided by
divided by
ab.
ab. Agree or not? Yes?
Isn't it XA minus, no, XB minus XA?
Oh, thank you. This is xa. Thank you very much. Yes? And now, this cosine alpha is the same cosine alpha here. So they have to be equal. Yes? This fraction and that fraction are the same because both of them are equal to the same quantity. So this means that what can I write? I can write xm minus xa over am is equal to xb minus xa over ab. Yes? But I have a nice relation between ab and am. What is that relation?
am is
AB is 2 times larger than AM. Why? Because I told you M is the midpoint. Yes? So this means that I can write XM minus XA. Instead of AM, I just copy and paste AM. But here, the numerator I copy and paste, but the denominator I write 2 times AM. Now what I do, I want to get rid of fractions always, if possible. So I multiply by 2am here and there. If I multiply this by, let me just write it down once. 2am multiplied by this fraction. And on the right hand side, I also do the same thing. 2am multiplied by this. So you see, I am mixing algebra and geometry. This is not geometry anymore. Geometry is finished here, trigonometry, yes? But now I am doing algebra. So, and then what will happen here? This AM and that AM are cancelled. What is left for me is a 2. So this becomes 2xm minus xa. On the right hand side, not only am is cancelled, but also 2 is cancelled. Yes? And then what will happen? It becomes xb minus xa. Yes? But what is my goal? Which one of these 3 numbers you see? I have xa, xb, and xm involved in this problem. Which one is missing? Which ones are given? xa and xb are given. xm is missing. So I have to look for finding xm using this equation. How should I do that? I multiply by 2. I multiply these 2 inside. Yes? And then I am looking for xm. My subject is xm. So I move this to the other side. So let me write here for you. So what is left? It's 2xm equals to xb minus xa. I move that to the other side. It becomes positive 2xa. And then positive 2xa, negative xa becomes what? Becomes xb plus xa. Agree? And now the final step, I want to find xm. xm becomes this number, which I write it the other way around. It doesn't matter because this is addition divided by 2, and that is exactly what Rasmus predicted, yes? So x sub m is xa plus xb. This is one way to prove this. But I want you to understand, I was not be able to find that, to write this algebraic formula. This is not geometric. This is equality between numbers. It's algebraic. I wasn't able to do this if it is not because of trigonometry here. Or trigonometry is part of geometry, yes? So I'm using geometry and algebra hand in hand to discover new rules, yes? And I want you to do the same exercise for yourself at home and find a connection between the y coordinates. You will see the same formula will apply. You can do it at home. I want you to do it if you are interested, so you get this formula. Yes? So this is an extremely important formula. So today's lesson is very important. I want to solve the problems for you later, but probably not today if you're so tired. But this I want you to write, okay? Let me finalize everything. So this is what I want you to summarize. So let me write it like this. Consider the points A, xa, ya, and B, x sub b and y sub b. Then, if D is the distance between A and B, and if M with coordinates x sub m and y sub m is the midpoint of the line segment AB, then we learn two formulas today. D is equal to square root of x sub a minus x sub b squared plus ya minus sub b squared. And then we also learn that, and so let me take this away. xm is equal to xa plus xb divided by 2, and ym is equal to ya plus yb divided by 2. So this is the content of lesson today, but we can solve good problems using this. So consider the points. If D is the distance between A and B, and if M with those coordinates is the midpoint of the line segment AB, then this is the formula for the distance, this is the formula for finding the coordinates of the midpoint. Okay, let me give you one example that this is useful here. So we will have a very long chapter in geometry later. So I want you to learn these words in geometry. So if you have a triangle, let me call triangle ABC. I want you to learn these words, that's good. if you take any random point on this BC, let me call it AX, yes, and then connect the opposite side, opposite vertex or opposite corner to this, this is called a Sevian line. So that's a Sevian line, that's a name. This is not in the book, but I want you to learn these words, they are not hard. So, if you take any point on this, and then connect that point to the vertex opposite to it, that is called a Sevian line. It doesn't matter if you take the point here, I can take the point there. I can take this point, for example, Y, and connect it to B. This is also called a Sevian line, yes? Another Sevian line. This is the general word, and you can do the same thing there. For example, I can take, I don't know, I can take Z here. I can take Z here, for example, and I can draw this line. So that is another one. So we have infinitely Sevian lines. But some of them are very famous in geometry for us. One of them that I want to introduce now is called the median. Okay? The median is a Sevian line which connects the vertex to the midpoint of the opposite side. That is called the median. Yes? So this is important for me that you know it. So this is optional, but median is actually compulsory. I want you to learn this word. So if I have a triangle, any triangle, ABC, I have exactly 3 medians. So I take the midpoint here. Let me call it M. M should be the midpoint. Not any random point. For Sevian line, X can be any point. But for the median, M should be the midpoint. And if I connect this point to that point, AM is called the median. It's a median, but I would write the median of BC. Or I can say the median of vertex A. So that is the median. How many medians are there for any triangle? 3. I can have a median here. I can have a median here. Yes?
Why is it called the median of BC and not?
No. This I have 3 medians. If I take the midpoint here, if I take this midpoint and draw this one, this is also a median, but this is called the median of AC because it is bisecting AC into 2 pieces. Yes? And then, of course, if I take the middle point here and connect that one, that is also a median, but there is a very, very nice theorem. The third one always passes through this point, which is not trivial at all. Okay, we don't want to discuss about that. That is beyond your book. But the third one always passes through this point, and that is the center of gravity of any triangle. So if you have a metallic triangle, very thin one, and if you find this point by drawing the medians, and then if you put it on the needle, it will be in equilibrium. Okay, it will not fall down. It doesn't matter how big your triangle is, whatever. So that is the center of gravity of any triangle. That's the physical property of that. So this I want you to know. So far I haven't done anything. I have just introduced you a word. Yes, do you have questions, Rasmus?
So the median, is that a line segment or?
Yes, it is a line segment, so that one vertex of it is a corner, and the other vertex is the midpoint of the side opposite of the corner.
But if it's called the median of BC or AC or AB, why shouldn't for example, the median of BC, shouldn't we also mention A?
Median of A?
No, but if the median is the line from A to M,
Yes.
shouldn't we also have to mention that A is part of the median of BC? Because right now we just call the line the median of BC.
Yes.
But
I mean,
No, by definition,
don't we also
people-
have to know where
no,
A
if
is?
you want, of course, you can say the median from A to the midpoint of BC. But when I say the median of BC, I mean BC is not a point. So this means the midpoint. And the other one should be a vertex. Which vertex? The opposite one.
Okay,
So you don't need to emphasize on A as
that's the
well.
definition of the word median.
So is a median always, are medians, when you're talking about medians, are you always talking about bisections of a triangle, or
Yes, yes. The median in the context of geometry is this line.
it has to be a triangle? On a
Yes,
triangle?
yes, only a triangle. Yes,
Okay.
yes. Okay. Now my question for you is this. I give you the coordinates of the vertices of any triangle, and I want you to calculate the length of the medians. Can we do that? Not algebraically, because it would be a very lengthy formula, that's useless. But let us just do it numerically. For example, I give you 3 points. I would say 1 and 2. B is -3 and 1. And C is -1 and 3. Yes? Well, let me make this one 5. Okay, so I give you 3 points, A, B, and C. You can draw them and see that they are the corners of a triangle. Now my question for you is that, what is the length of the median AM? What is the length of the median AM? Okay, so let me give you a better picture, if this picture is a good one. So let me draw it here. Do I have enough space here? So let me clean this. Okay, so if I want to be a little bit careful in drawing the pictures, so here, let us just do that. A is 1 and 5, so it is 1, 1, 2, 3, 4, and 5. This is my point A, for example. My point B, -3 and 1. This is my point B, 1 and 5, -3 and 1. And where is my C? It's -1 and 3. -1 and 3. So it's really awful. So let me just change this one. Minus, because then it would be hard for us to see it. Let me make it +1 and 3. +1 and 3 is not good. Let me make it +2 and 3. +3 and 4. It's better because I want to see the picture. It's hard to draw good pictures. So 1, 2, 3, and 4. This is 3 and 4. And now this point, and this point, if I connect them, it becomes a triangle. Yes? My question, of course, I don't know. This picture is not precise at all, so I really don't know. Is this really the midpoint or not? We have to discover. Okay, but what I mean that you need to go and find the middle point and connect A to M. I don't know if the middle point is really here or not. We can discover by algebra. And then I want you to calculate the length of this green line segment, which is the median corresponding to this BC. So how should I do that? I need 2 formulas. The distance formula, because I want to find this length, but I also need the midpoint formula. Why? Because I don't know the coordinate of the midpoint. So what should I do? I have to calculate. Okay, I calculate xm and ym. M is the midpoint of BC. So it is x of b plus x of c divided by 2. and this is y of b plus y of c divided by 2. Yes? Because m is the middle point of BC. But what is x of b? It is given. And you see that that was not a coincidence. This is exactly on the y-axis. Why? Because x of b is minus 3, x of c is 3 divided by 2. It becomes 0 over 2. It becomes 0. And then y of m is y of b, which is 1 plus 4 divided by 2. It becomes 5 over 2. So if I ask you what is m, m is x coordinate is 0 and the y coordinate is 5, 2. Even though my picture was very, very poor, but it was a good one. Yes, because we were able to see that the x coordinate is 0, so it is on the y-axis, and the y coordinate is 2.5. It is approximately correct. And then I have to use the formula for the length AM. The length AM is the x of A minus x of m to the power of 2 plus y of A minus y of m to the power of 2. But we already have these numbers now. X of A is given to be 1. X of m, I got it myself. You cannot guess. Even if you have best tool in the exam, you have to write them down. To the power of 2. And what is y of A? Is 5. What is y of m? Is 5 over 2 to the power of 2. Okay, then you have to calculate that. So this becomes 1 minus 0, 1 to the power of 2, 1 plus 5 minus 5 over 2 is 5 over 2 to the power of 2 is 25 over 4. But 1 is 4 over 4, so it becomes the square root of 29 over 4. So this becomes the square root of 29 over 2 length units. So that is the exact value, which geometry is not able to give us that exact value. We have to use algebra. So the exact length of this, if I draw it correctly, would be square root of 29 divided by 2. That's the exact value of the median. Okay, I will stop the lesson here and then we continue tomorrow. I will update you which part of the book you have to study for today. Yes, thank you.
Wow. Oh.